I would like to thank for the STEP team to this opportunity to present my overview about exploratory data analysis. Firstly, I will present a short introduction about this expression. Okay, introducing this EVA by in the study plans, also in presenting the data flow, the data workflow when we have to process all the data since the raw data from until the insights that we have to achieve. In which I also outlined what is the importance of using some descriptive statistics and some inferential statistics. Finally, I will conclude about the topic. Firstly, it is important to take into account that this expression, exploratory data analysis, was introduced by Tukey in 1977. Firstly, this term was introduced in terms of collection of by using some arithmetic operations and graphical techniques, and that author designed them to perform some work that he named the numerical detective work. This term was some developed over the time. And now today this ABA also it corresponds to the first stage, the step or first stage in develop advanced analytical models. This is a stage where in short we can achieve the first characteristics of the data, what are the main meanings of this data. After this, it is important to contextualize this term, okay? It is important to define that the data is related with some research questions that the decision maker have to define. Regarding these research questions, it is very important to identify what are the subjects or cases that should be studied. And for them, we need to identify what are the more relevant variables that we have to collect data. Okay. Regarding these subjects or cases, it is very important to take into account if we have the availability of the whole cases, all subjects that corresponds to the population, or we only have a sample, a set of cases from this population. In the majority of the cases, it is very expensive to collect all the data, and it is important to take into account that some care we have to take if we use samples. Okay, although nowadays we have a massive availability of massive data. Regarding the samples, if we have to handle samples, it is very important that the sample represents in the right way what happened in the population. This means that each, in what situation we have a random sample. Basically, when each case or each subject of the population has the same probability to be collected in the sample. So we have different methods to sample to achieve a random sample, like a simple random sample, systematic. So it depends on the characteristics of the population. But it is important to have the objective is to have a random sample that represents what happened in the population. In the other side, it is very important to take into account how these data will be collected. Okay, we have basically two kinds of studies. The observational studies, in which the decision maker does not have directly influence in the way in which the data is collected. So these examples can be when the decision maker uses data, the global sources that are available, data that are available in free databases, or also in the cases when this data is collected from through surveys. So in this case of the studies, in terms of the results, we only have that the decision maker can make some associations between the different variables. Okay, so in the case of experiment, in this case, the decision maker will interfere in the way in which the data is collected. Okay, because the subjects or the cases are randomly assigned for each group that could correspond some levels of factors that are important to evaluate the effect. Basically, in this case of situations, the decision maker can establish a causal relationship between the response variable and the explanatory variables. So for this situation, we have the design and analysis of experiments. We will have a workshop about this in the next month. After contextualizing the study planning, it is very important it is necessary to collect data that is planned in the study. But sometimes this raw data we need to organize it to be suitable and processed by the computer. Right? Basically, probably the data are collected from different sources. We have to integrate all the data in a file that will be processed by the computer by some software. Right? And after this, we have the stage of exploratory data analysis, in which the objective is to find the first insights and to identify some associations, patterns, trends concerning all the variables that we have. These insights are very important to decide also what is the suitable advanced analytic model that the decision maker can use in the next stage, and also it is very important and also today this workshop will detail this process of exploratory data analysis. Basically, what is what methods that we can use in this stage. So all the methods that the decision maker can use them to retrieve, to derive some insights about the data. We need to achieve some knowledge about this data, the right knowledge. So for this, we use some visualization methods, plots, graphs, different, also some descriptive statistical methods. In which we want to summarize the knowledge about this data. Basically, it is very important to uncover what is, because sometimes we have a lot of data and it is important to identify what are the more important variables and also the associations between variables, and identify the initial set, the initial insights to decide what is the best method that we can use in the next step. This is a process. So I represent the ADA process by using circular figure. Basically, this has some rationale. Also, in the first stage is basically very important stage, that is the data processing. So the data processing is basically we do not. It is very important to take into account that we cannot directly go to the data, because the data has some problems, some errors, some also duplicates, also the data can be inconsistent, and it is very important to solve these issues before to go to the graphical analysis, the descriptive analysis. So because if the decision maker go to the make this analysis, probably this step will be failed, okay, and could be also counterproductive for to support the decisions of the decision maker. It is very important to clean the data, and also basically to organize the data file before making this analysis. So after this, it is very important to after we achieved a clean file with the variables regarding the subjects or the cases. It is very important to summarize this information using some statistics that summarize the knowledge. Also, it is very important to analyze each variable by using what I name the univariate analysis, and also to identify the relationship between two variables and more variables. And in this process, is a circular and systematic and a flexible process, because sometimes we need to handle the data to achieve the insights in progressive way. Okay, so sometimes it is important also that the decision maker has the knowledge, the required knowledge, because sometimes it is necessary to collect more data. So and also data processing and so on. Okay, this is we can name this process a process of flexible and systematic handle the number, treat the numbers, treat the data to produce knowledge, right? And also it is very important to take into account. So in this process, the first things that the decision maker should take into account is the type of variable, because we have different natures of variables. So what is data? Data represents some numbers or some categories of this data. So the variable can be qualitative, and also we can have nominal variables that are represented by different categories that are not ordered. Also, we have other qualitative data, for example, the satisfaction level, when we can ordinate these categories. So, in the opposite side, we have all the quantitative data that are represented by numbers. So if we identify all the numbers, we can classify the variable as a discrete variable, or if the quantitative variable is measured, this will be a continuous variable. So this is the nature of the variable is very important to identify what are the suitable statistics and also the suitable graphs to represent these variables. Sometimes in the software, if we do not identify or do not handle this problem, or if we do not solve this problem, so the software will give you the wrong results, and this is due to the problem of the data is not classified is incorrectly classified. So, in one problem of when we will begin to handle the data is a problem of missing variables. Okay? We do not have some observation are not available. So it is very important to see if the problem of this missing data is related to the problem when the variable is the true score of the variable is null, is zero. Okay, so it is very important to identify if this happens or not. Also it is important to see what is the percentage of missings in our data set. Basically, so we do not have in the literature some rules, okay? This can depend also the decision maker, okay? If we have a large percentage, more than 50%, but there are other rules, okay? Probably it is best to drop the variable. The problems occur where the variable is significant, and in this case we can replace by other that can be correlated with it. Also, if we have a small percentage of missings on the data set, we can solve this. So we can have different ways to solve this, but this depends on the distribution of the variable, the nature of the variable. For example, for the quantitative variable, we can adopt the mean, but if any change that we make in the data, it is very important that this change does not change the distribution shape of the variable. Okay, so the mean could be a good process in the case of when in which the distribution is symmetric, but if the distribution is not symmetric, it is better to use the median. In the case of categorical variables, the mode is an option, but it's very important to see, to see the data and relate this subject with subjects, other subjects that have the same figures. The features, and also probably it is better to see what is the missing for what is the category for the other variable in which the variable the subject is similar. So in identifying so also the missing methods that depends strongly for the method that we use as advanced analytic model, okay? Because there are some methods, for example, the frontier methods, in which we use the minimum value of observed, right? These are some roles that depends also on the decision maker. Regarding the outliers, it is other problem that the decision maker should solve. So basically these outliers can be detected, for example, by using, by identifying some extreme observations. In this case, in the box plot figure that we have two outliers on the right, okay? After the per whisker, and for example, in this scatter on the right, we have these observations that are very far from the remaining observations. So we can also calculate the z-score, also to identify the observations that are extreme. Very different from the other observations. So it is very important to see why these subjects or cases have this kind of score for that variable. So probably some problems can occur because we can have a problem of data, error in data collection, and so on. So, but it is very important to identify if we will not have an error in the data. It is important to see why try to explain why this subject have these extreme observations. Also, the treatment of these outliers depends on the next method that the decision maker will apply, and also there are some solutions that depends on the decision maker, but can be, for example, drop the variable. The problem with this is like the missings, right? We delete some useful information about the other variables. Other can be adjust these extreme observations for points lower, closer to the lower and the upper whiskers of the points that are observed. Okay. So after we handle the problems with data, duplicates, problems with data types, problems with missings and outliers, we can apply directly the statistics, summarize the data. Also using and also make some visualizations, right? So in terms of the descriptive statistics, we can adopt different kind of measures, like the central measures, also dispersion measure, also other measures, but these central and dispersion are more more common also, but in central measures also depends on the distribution of the variables. Okay? So if we have a categorical variable, it is better to use the mode. In the case we have nominal data. Also, if we have a variable that has a symmetric distribution, I mean, it's a good option. And in the case of an asymmetric distribution, the median could be a good solution to define what is the central measure of this data. So in terms of dispersion measures, so basically so if we see these distributions that we see in this slide, we see these distributions have the same mean, but we see that these distributions will be a low dispersion than this distribution, this more flat distribution. So it is very important to calculate some statistics that represent this, that more or less we see the variance that is the measure, the deviation of each observation from the mean. But we scare these deviations and divide by the number of observation -1, which is a sample. And also a standard. So the problem of the variance, it's the problem, no, but the unit of the variance, it is a unit squared. So this is why we use frequently the standard deviation. But for example, in your data set, probably you have a lot of variables in different measure in different units, and to compare them, it is very useful to use the variation coefficient, because by comparing them, by comparing the dispersion of different variables, we see what are the variables that in which the highest dispersion is observed. Also, other measures are the interquartile range, which is the difference between the third percentile and the first percentile. Also, if the distribution is not symmetric, it's a good measure, the interquartile range, to define the dispersion of the data. So we have other measures that measure the symmetry of the distribution and the kurtosis and so on. But frequently we see so decision maker with these measures. So after this, it is very important to it is important visualize the data. So we see that a picture is worth more than 1,000 words. Okay, so basically it is important to also in communication the insights, the graphs are very useful. Also by using the plots, it's a good way to inform the insights of the data in a universal and effective way, and also in the communication of the insights frequently uses the visualization of data, or the visualization of data is very effective in communicating the insights. Okay. So in visualization, so this also depends on the nature of variable. Okay, so if we consider a univariate analysis for continuous variables, so how the values of the variable are distributed, an histogram can be used, okay, and also a box plot. For example, in this case, we see the distribution. So we do not see, but so the histogram, we will see how the variables, how the values of x of the variable are distributed in the domain of the variable. Okay, also the box plot, it can translate this, but the advantage of histogram is it is in terms of we observe the concentration of the data in different intervals of the domain of the variable. So if the variable is a categorical variable, a categorical ordinal, or we have a discrete variable, quantitative discrete, we can use a bar plot, basically to see what is the frequency of observation for each category or for each value of the variable. So in the case of, for example, in the case when we have a categorical variable with multiple categories, the Pareto plot can be a useful plot to decide what are the most important categories for the variable, and also we concentrate our attention for those variables. More or less 20% of the categories are more important than the others. Also, in the case when so these are some examples in univariate analysis, but for example, if we consider the more than one variable, for example, the bivariate analysis in which two variables are so in which two variables are related, okay, it is important to see, okay, how one variable is correlated with other, what is this, we have association or not. So for this we can use a scatter plot. Also, other important, in the case when we have the information of time. So it is a good practice to represent the time on horizontal axis using also the scatter plot. In the case when we have a continuous variable and another variable that has different categories, it is important one useful graph or plot is a box plot. So also we can, for each category, we define the box plot for a continuous variable. Okay, so in the case, other options are in the case where we have two categorical variables based on a contingency table. So in this case, we can use a stack bar plot or a mosaic plot to see what, and in the same graph, we can represent two variables. In the case when we have a multivariate analysis, so it is important to see what is the relationship between each pair of two variables. So it is important. So in the same graph, we can see, for example, on softwares, on specific softwares, we can visualize what is the relationship between each pair of variables in the same graph. And also it is a good way to make a multivariate analysis. Also, we can also represent the correlation between each pair of variables by using the heat map chart. So these multivariate analyses are are applied for the case of when we have continuous variables. These are basically the objective of this visualization of these graphs are to obtain insights of the associations, the trends, the patterns. Okay. And sometimes we need to analyze or to make another variable. Okay, we can make a multivariate analysis, but sometimes we have again to make a summarized statistics or a multivariate analysis for a variable that has not been studied. So and it is necessary to study and to relate with others. Okay. So this is a flexible process in which the main object is to understand the data, to obtain knowledge about the data. When in the case when we have samples of this data, we make some analysis, we have some summaries like the mean, like the standard deviation, but it is very important to take into account that these summarized represents summarized samples. Okay, so it is very important to how we can generalize for these insights for the population. So, and in fact, in this situation, we need to use the inferential statistics methods that enable to draw conclusions about the population, taking into account the information that we have on the samples. And this can happen in the real world problems, like in quality testing. Okay, is a new process, the manufacturing process, better than the old process. Okay, basically, for this, the production measure probably we will use samples. Okay, and one would like to know what happened with the population. Okay. So to go from the exploratory analysis in using samples to the populations, this process is the inference. It is very important that the generalization is only valid if the sample it is a random sample, represents the entire population. So we see that, if in experiments or in observational studies, we see if the subjects are a random sample, we can generalize for the population. So we can use the results of the sample to generalize them to the population. But if the sample is not random, these results are only applied for the sample, okay? And it is not possible to generalize them. So this is why it's very important in study planning, take into account that the sample should be a random sample, a good representation of the population. If you do not, sometimes you have access to all the data, but frequently the decision maker do not have all the population. So how we make this, okay, if the sample is a good representation of the population, is a random sample, how we can generalize these results for the population. So we can see that, okay, we have a sample, okay, and different samples will have different things. Okay. and with a very low probability, the mean is equal to the true score of the parameter of the population. So basically, what we make when we calculate, for example, the mean of a sample is a point estimation, right? For example, the population mean is estimated in 60. Okay, represented by this pink point, okay, in this figure. So this is estimate, a point estimate of the sample that can vary, that will be different from another sample and another sample and the other. Okay, so it is very important to have some method that catch the true score, okay, the true score of the population, the true mean of the population. So we can use the confidence interval. So basically, rather than tell that the population mean is 60, we should say that the population mean should lie between 55 and 65 with 95% of confidence. We have different levels of confidence. Okay, so in this case, we see in this example, so we have the mean. So, and this confidence interval, it is the mean minus margin, error margin. And also this means that if we have a large number of samples, and if we calculate the confidence interval for each sample, probably on average 95% of these intervals calculated will include the true mean of the population. So basically the confidence interval give us a confidence interval of the generalization of the statistic for the population. But the decision maker can be interested in testing the plausibility of some hypotheses. So about the population parameter, for example, the mean. So the decision maker can want to test, for example, if the mean of the population is higher than 40, for example, and assuming that until now the true mean is considered equals to 40. So the 40 is the status quo. Basically, the hypothesis testing method only define hypothesis, defining in null hypothesis what is the status quo of the knowledge in terms of the parameter, and in alternative hypothesis, it is we should define the opposite what is written in the null hypothesis. Basically, the results of the hypothesis testing is basically reject or not reject the null hypothesis, is the result of the confidence interval. And also we have, so the results of the confidence interval, if there is a relationship between a confidence interval and the hypothesis testing, that okay, the hypothesis testing do not reject the null hypothesis for the values of the confidence interval. Okay, for all the scores that are in the confidence interval, the null hypothesis will not be rejected. Okay. Also, this we have different hypothesis testing. Also, and also the confidence interval, basically the confidence interval and the hypothesis testing are based on the distribution of the statistics. And also we have assumptions that we have to test and should check before to apply a confidence interval, to apply also the hypothesis testing. Also, the different confidence interval and also hypothesis testing are dependent on the variable that we want to generalize from the sample to the population. So if we have quantitative variables, we are interested in the mean, or the mean or in the variance, to test the variances or the mean. But for example, if we have a qualitative variable, the decision maker will be interested in testing the proportions by using one sample or two samples, or for example, to identify the independence of two categorical variables. So we have different, so these are some of them are parametric, so the means, proportion, and variances, and the frequencies. So the t-square is a non-parametric test. So if we can conclude about this topic, exploratory data analysis, this stage can solve problems about the data quality, like some duplicates, missings, incorrect values, and so on. And this stage, this step is crucial to and should be done before to apply other to calculate statistics to plot graphs. Also, the exploratory data analysis can play a vital role in obtaining knowledge about the data. By using descriptive statistics and inferential approaches. Also this process of EVA, we can characterize it by some systematic and flexibly network that enables progressive interpretation of data. And based on the insights of this data that we achieve in the final stage of EVA, it is this knowledge is very important to decide about what is the suitable advanced analytical method that we can apply, the decision maker can apply in the next stage. Also, it is very important that the insights that the decision maker achieved during this stage are very important and also to support critical analysis in subsequent stages of analyzing and applying the more advanced analytical methods. Finally, all these the open source softwares like R and Python provides essential tools to support the EVA and also to support to apply the more advanced analytic techniques. Thank you for your attention.